Hello everyone, in this video I'm going to be going over the examples in the 7.7 notes. I'm going to talk about them a little bit, just the notes overall, but then go into detail with the examples. So, here we have a model pyramid versus a real one, and the point of the model pyramid is to be a small representation of the real thing. If you don't have access to the real thing, you'd want to build something smaller, but it's like looking at the real thing, just a much smaller size. So, in our first example here, we actually switched to a model of an airplane that is 10 inches long. The length of the actual airplane is 160 feet, and it wants us to write the scale of the model. The scale of the model is a vocab term. You don't really need to be super familiar with the definition, just understand that the scale of the model is comparing the size of the model to the size of the actual thing. So when you write this model, the scale of the model, you have to put the model number first. So whatever measurement goes with the model, and then you put the actual number, so whatever number goes with the actual thing, that goes second. And you include the units when you write this out. So with the pyramids, it was pretty straightforward. It was 5 inches to 454 feet. This one requires a tad bit more work. So the model of the airplane is 10 inches long. And feel free to abbreviate as when you can. And then the actual airplane is 160 feet. Now the reason I didn't just straight write this into the boxes, hopefully you noticed that you can simplify these two numbers. Reminder, in this unit, simplifying is expected, always. So I can simplify both of these by 10. Just a tip, when you have a number that ends in 0, you can always divide it by 10. 10 divided by 10 leaves me 1 inch. 160 divided by 10 leaves me 16 feet. So my new scale of the model is 1 inch represents 16 feet. It's better to work with smaller numbers anyway, because these are a lot easier to grasp than when we get into larger amounts. So hopefully it'd be easier to grasp that if you have a model of an airplane, 1 inch on that plane represents 16 feet in real life. Let's take this a bit further. If the wingspan of the actual airplane is 144 feet, how long is the wingspan of the model airplane? So now that we have a comparison, we can use that to find any measurement on the actual airplane and or the model airplane, depending on the problem. So what we do is we take the scale of the model, which is 1 inch to 16 feet. When you have units, I even want you to include that as well. If you keep track of your units, it organizes the problem and it shows that you have a better understanding. So I'm going to rewrite this as a fraction, so instead of ratio form. So I have 1 inch on top and 16 feet on bottom. Just a reminder, you always write the model first. So model's always on top, actual is always on bottom, that's the form, and it will always be that way for these problems. You never flip it. So since we have 1 inch over 16 feet, whatever we put on the right side, the top is going to be in inches and the bottom is going to be in feet. And then we need to figure out what else to put in here. So if we go back to the directions, they mention one other thing, and this is 144 feet. We have to put it in one of these two places. It goes in the bottom. A pretty simple way to see why it goes in the bottom is it's feet, and we know feet is on bottom, so 144 has to go on bottom. However, we will have problems where they're all in feet, everything. So then how do we tell? If you go back to the directions, if the wingspan of the actual airplane is 144 feet, this goes with the actual airplane. Meaning, we have to put it on bottom because that's where the actual numbers go. So that's another way to tell. And then whatever's left over, that's what we're looking for, so this is going to be X. The setup is very involved, obviously, but the solving is very straightforward, is what we're used to doing. So once you have it set up, we're going to cross multiply. I know some students have a lot more experience with units than others, especially if you're in like a chemistry class. That's one place you'll definitely use units. So when you cross multiply, keep the units over here. Don't bring them over to your equation. That will cause more confusion. 1 times 144 is 144. 16 times x is 16x. There's our equation. Then we solve like normal. So we divide both sides by 16. 16 divided by 16 cancels, leaving just x. 144 divided by 16, which I will show you with my calculator just to make sure you believe me. 144 divided by 16, you are supposed to get, ooh, that is bright. Give me just a sec. Alright, I fixed my brightness. Sorry about that. Okay, so 144 divided by 16 is 9. So x is 9. Last thing, always ask yourself this question when you're doing these types of problems. 9 what? 9 inches. How do I know what the unit is? Reminder, I'm solving for x. X is 9, and x is attached to inches here. So my final answer will be in inches as well. Again, make sure you're keeping track of the units. At the bottom here, I'm going to talk about this very briefly. You're going to have a problem that asks you about an item that is set horizontally or set vertically. That item will have a rectangular shape. So if it's set horizontally, you will set it up like this. Your length is on bottom, your width is on the side. Whereas if you have it set vertically, your width is now on bottom and your length is on the side. So essentially we take the horizontal and we turn it to look like that. So this is just to help you set up your pictures. It's nothing super important except for on literally one problem. So when you get to the problem that mentions set horizontally or set vertically, please draw the pictures. It does really help. Backside. Example 1. So let me backtrack just a little bit here. At the top here we have scale or scale factor. That is different from scale of the model. They have a very similar definition. The big difference is that in the scale and scale factor, they mean the same thing, but you'll see it written both ways. You have to have the same units on both numbers. So on the front side we had a number in inches and a number in feet, but they were together in the same ratio. That does not happen when we're using scale or scale factor. These numbers have to be in the same units. So they have to both be in feet or both be in inches or both in miles. Whatever your measurement is, they have to be the same. So when we write the ratio, we don't include units. And let me specify no units, and I'm going to add a little caveat here. No units written. So when we write this ratio, we don't write the units with the numbers, is what that means when I say no units written. That doesn't mean that it doesn't have units. These have units, but we don't write them because if they're the same, we can drop them. So let's look at example 1 so you can see what I mean by this. The scale for a model car is 1 to 8. Notice that this here has no units written. If the model car is 2 feet long, how long is the actual car? So again, we start with this ratio we're given, 1 to 8. We're going to rewrite this as a fraction. 1 on top, 8 on bottom. Now again, the units here are not written, but there are units. If you look in the problem, it says if the model car is 2 feet long, you have to look for where does the problem give me units, right here. That means that these are all in feet. This is 1 foot and then 8 feet on bottom. That means that the rest of this is also in feet. I'm going to kind of reiterate all of that because I understand that this could be a bit confusing. This has no units written in it because we know that they have the same unit. If they have the same unit, we don't need to write that down because we understand they represent the same unit. So then we look elsewhere in the problem. Okay, where else do they give me a measurement? That will tell me what units we're looking at. Here they gave it to us. They're like, okay, the whole problem has to be in feet then. So that's why I can make this assumption here. Now let's place this. If the model car is 2 feet long, 2 has to go on top because it goes with the model car. And remember, Model is always on top, actual is always on bottom. And then we're trying to find the length of the actual car, so that's where X is. Again, once you set it up, it's pretty straightforward. We cross multiply and solve. 1 times X is just X, or 1X. 2 times 8 is 16. There is no solving needed here because of the 1X. One other thing I can add on, 16 what? Feet. If you're not sure, look back in your proportion. What was X attached to? Feet. That's the units on my answer. X is 16 feet. Example 2 is going to be very similar to example 1. The scale for a model car is 1 to 8. We're still working with that. If the actual car is 72 inches wide, how wide is the model car? So we have 1 to 8. We're going to change that to a fraction of 1 on top, 8 on bottom. This time, if we look for the units, it tells us that the actual car is 72 inches wide, meaning the whole problem has to be in inches. Since these don't have any units, we have to look elsewhere. It mentions inches, so the whole thing has to be in inches. It's technically 1 inch on top, 8 inches on bottom. So then you've got inches, inches, inches. If you need to, I'm going to go back to the other side of the page real quick. Just a refresher on how that contrasts on the front side. We had inches on top and feet on bottom for this problem. That's because we had different units, and then on top of that we had to include those in the ratio because they're different. If they were the same, we could drop them. So just some things to think about, the big differences between those two types of problems. All right, let's finish this problem. If the actual car is 72 inches wide, 72 goes on bottom because it's the actual. So then we're trying to find the width of the model car, so that's going to go on top as X, and it is in inches. Once again, when you have it set up, it's pretty straightforward. Cross multiply, solve for X. 72 times 1 is just 72. 8 times X is 8X. Then we solve. Divide by 8. This cancels, leaving X. 72 divided by 8 is actually just 9. And then again, 9 what? 9 inches. If you're not sure, look at where your X was. It's here. It's attached to inches. Inches is your final answer. I want to specify something real quick because I got a question on this today. It's actually a really good thing to think about. So like in the first problem, it was talking about length, and this one's talking about width. And so it's not about like where we put the length or the width of the problem. That's just what we're looking for, but it's not something we think about when we're setting up the proportion. When we're setting up the proportion, we're thinking about two things: the model over the actual, and then when they give us something, we have to figure out, okay, is it model or is it actual? Just about reading the directions and putting the numbers in the correct places. And then, of course, assigning the units where they go. Those are the main things to think about. I wouldn't get too caught up on the words, length, width, height, all those in these problems. Last one, number 3, and this one is a bit different from the first two. The scale for a model car is still 1 to 8. If the actual car is 5 feet high, what is the height of the model car in inches? So again, we start with 1 to 8. We write this as a fraction, 1 on top, 8 on bottom. No units, let's keep reading. If the actual car is 5 feet high, those are our units, feet. So we have 1 foot on top, 8 feet on bottom. So then the whole thing is in feet. 5 feet high. The 5 goes with the actual car. So we are going to write the 5 on bottom. Model on top, actual on bottom, 5 feet on bottom. So then this missing piece is my X. That's what I'm looking for. So now I can solve per usual. Cross multiply. 5 times 1 is 5 equals 8 times x is 8x. Set up our equation, then we solve like usual. Divide by 8. This cancels. And then 5 divided by 8 it is 0.625. By the way, when you get a decimal like this one, this is actually what I would consider a nice decimal. It's not too long. I wish it were obviously a bit shorter, or not a decimal. I'm not a fan of decimals, but sometimes, a lot of times, we work with decimals in the real world. So, a lot of you would probably look at this number and be tempted to go ahead and round this to 0.63 or take it to 0.6. Or, if you're bold enough, take a 0.6 and round it all the way up to 1 whole. If you have a decimal like this, leave it. Remember, rounding a number is changing a number. And we don't want to change our numbers if we don't have to. It's kind of a necessary evil, rounding is, but it's not something I prefer to do. So x is 0.625, and again, always ask yourself that age-old question. 0.625 what? If you're not sure, look in the proportion. That is x. X is attached to feet. If you're paying close attention to the directions, it asks, what is the height of the model car in inches? They want your final answer to be in inches. Right now we have it in feet. Some of you may be like, well, let's just change that. How about I just write 0.625 inches instead. Slapping a new label on the number doesn't make it actually in inches. This is in feet. If we just change the label, you don't change anything about the number. You're not doing anything to make that actual change. So we have to do something that you should be familiar with, at least the term convert to inches. You can convert between all kinds of things, but inches and feet is the most basic thing that we use. So I'm going to show you kind of the breakdown of how I do this. And just for space purposes, I'm going to put this on a Post-it note. So personally, not a fan of conversions. I never have been. They've always been a struggle point for me. So there's a method I use that you can use on this problem, on any conversion problem. So conversion method, you start with what I have. So that will go here. Then this is a times sign. So this is what I have. On top, you're going to put what I want. This is going to be the unit. And on the bottom, you will again put what I have. And that is the unit that I have. So what I have will be the full number plus the unit. These will be just the units that I want, and then I'll go from here. So I could have explained that a little bit better, but hopefully when I go through it, it makes more sense. So what I have right now is 0.625 feet. So that's going in this blank here. Then I'm going to make a ratio. So looking at the units only, on top, what I want in units, I want inches. So inches is going to go on top. What I have on bottom, that's the unit, not the whole number. I have feet. I want to get rid of feet. Now I'm not going to put this 0.625 into here. So then after that, fill in the conversion. So that's what I'm going to put into here. That's where the numbers are going to come from. Now, a conversion is a relationship from one thing to the other. So really you're asking how many inches are in a foot, or it could be vice versa. It just depends on what you're looking at. So in this case, we have 12 inches is in 1 foot. This is just general knowledge. It's ideally something you picked up in elementary school, but if you don't have these fully memorized, that is completely understandable. On top of that, we'll be giving you that information, so I wouldn't stress too much if you don't remember this off the top of your head. Just know how to set it up. That's my main thing. So I want inches. Those are going to go on top. I want feet on bottom because that's what I have. And also why I do this. When I do the multiplication, my feet cancel because I have one on top and one on bottom. That's why I want to do this. So what I need to do, if you want, you can put this 0.625 on bottom. Sorry, I don't know what I'm saying. Put a 1 under this 0.625. It's not going to change anything, but I know some of you really need that something under it to make it make sense. On the bottom, it's just 1 times 1, so you're not going to have anything there. Really, all we're doing here is 0.625 times 12. So let me show you what you get when we do that. 0.625 times 12. We get 7.5 feet. Sorry, inches. I have been doing that all day. Inches goes on top because we got rid of feet. So inches is left. Do the math. You get 7.5 inches, which is what we wanted the answer in inches. So now we are done. So the reason for this method is if I flipped this fraction, just to kind of give you a what if scenario, so it's clear why the method is helpful. Because I know some of you just get conversions, like it makes sense in your head. If this is one of the few things in math that just don't come naturally to me. I have to think so hard about, do I multiply by 12? Do I divide by, I don't. If I have this in front of me, I don't have to think about it. So if I were saying wanting to find feet instead of inches, I would just flip it. Put feet on top, inches on bottom. And then I would divide by 12 instead of multiplying. That's if I had inches and I'm trying to convert to feet instead. So see how it works depending on which one you're doing. So here we're converting to inches. We want inches on top. If you wanted feet, you'd put feet on top instead. And so then you would divide by 12 instead of multiplying. So that's why this method is so convenient. It is, and it works too. And it's easy to remember. So I don't have to sit there and strain myself trying to think about what I would do instead. One more thing at the bottom here is your homework assignment. It is the Knowledge Check 7-7 review. It's on Canvas. You have unlimited attempts. And on there, I ask you to get at least a 10 out of 16. A 9 out of 16 is an F. A 10 out of 16 is a passing grade. So 10 or higher, you'll get a passing grade on it. I will bump this 10 up to a 16 or whatever number you get. But it has to be at least 10 for me to bump it up and give you full credit. This is great practice for the real thing, which you will be taking tomorrow. Or if you're not watching this in real time, that would be February 28th, Tuesday, is when we are doing the knowledge check, the actual knowledge check to go with this. And I have the due date set for tonight, again, Monday, February 27th at midnight, because that's when I want you to have the practice done for it by. If you have any additional questions over these notes, any of these examples, feel free to let me know. Otherwise, you all have an awesome day. Bye.